Hello and welcome to the Edupedia world. In this tutorial, we'll be learning about coupling and cohesion. Basically, what are the characteristics of good design? The characteristics are component independence, that includes high cohesion and low coupling. What are they? We'll cover shortly. Another one is exception identification and handling. So to identify the exception and how to handle it, that is exception handling, is also a characteristics of good design. Then we have fault prevention and fault tolerance. So just to ensure that fault should not be there in your application is also a characteristics of good design. Then design for change. Your design should be, easily updatable and easily changeable without changing, or you can say without doing much of the code changes and without, making changes in the architecture. So if I should rather write it, design should be for extension, not for changing. Because if you want to extend anything, or even if you want to change anything, then also it should not be there that for a single change you need to just modify 10, 15 files. It should be such that by making a change in one place, it should get reflected to all the places. Just for an example, if you are doing a change for currency symbol, then it should not be everywhere. Then on each and every screen you need to go and you need to make the change. It should rather be, placed in a or coded in a way that by just changing in a one place, it should be reflected into all the places. Okay. So now let's see what is cohesion and coupling. So first we will cover cohesion. Cohesion says that the degree to which all elements of a component are directed towards a single task, or degree to which all elements directed towards a task are contained in a single component, or the degree to which all responsibilities of single class are related. So basically, it says that all components of your element should be directed towards a single task. So there should be an internal glue with which components is constructed. All the element of components are directed towards an essential for the performing the same task. So, if you are having 10 classes and or you can say the 10 components in your project, so it should be, like all the elements of those components should be directed in the or, made to work for the same task. So that, if they are like highly coheted, or what should I say, the cohesion if high, that means all the elements are basically directed towards a single task. So like this is what we say as high cohesion. So we have different types of cohesion like functional, sequential, communication, procedural, temporal, logical, and coincidental. So these are types of cohesion which vary according to the context in which we are talking. If we are talking the functional aspects of our program, then we will talk about the functional cohesion, and similarly for the others. So what is coincidental cohesion? The definition says that parts of components are unrelated. Fine. So unrelated parts, processes or data. So cohesion, coincidental, that's on a lower cohesion side. So the parts of components are only related by their location in source code. So that means if there are controller classes, then it should be placed in one package. If there is a classes that is accessing to the database, they all should be located in another package. So they should be located where they are related to each other. So that means coincidental cohesion. Elements need to achieve some functionality, are scattered throughout the system. So if that is an like accidental case or the worst form of cohesion, if it's scattered. So the example are like there is like print next line, then reverse the string of characters in second argument, add 7 to 5, convert 4 argument to 4. So you can see these are 4 lines of code which are actually unrelated. So it's not like if print next line, after printing the next line we should do something that should relate to the first line, but what second line is doing is anywhere not related. Rather we should arrange it in a way that it should make some sense. Next is logical cohesion. So that means element of components are already logically and functionally related. So that means several logical related elements are in the same component and one of the component is selected by client component. So if they are logically related, then they should be in the same component. By logical relation, I mean to say, there should be like, as we have seen in a previous example where we are having four statements. So they were written in a way that they were not making any logic. The sequence was not correct. So if we need to sequentially align them, we need to assign them or we need to write them in a way that makes some logical sense. So that is about a logical cohesion. So the example are component read inputs from tape, disk and network. So since there is a component that is reading input from these three, they should be like kept in a single location. Okay, or on a single package. All code for these functions are in same component. The operations are related, but functions are significantly different. So you see, the operation is to input or to read the input, but the operation, that is where to read it. Like for to reading for the tape, we need to write a different code. To read it from the disk, we need to write a different code. To need to read it from the network, we will have a different code. Then we have temporal cohesion. Temporal cohesion says elements are related by timing involved. So that means elements are grouped by when they are processed. Okay. Example, an exception handler that closes all open files, creates a log, notify users, and lots of different activities occur at the same time. So all these things, should only occur when an exception comes up. So that's why we write all these things as a part of a catch block, or we made like call that method which is doing all these things, or we can call different method. So you can see how the things are related to each other according to the timing that is involved. So if there is an exception, then only these will get called. So let's move forward. Okay, so next you can see there's an example which says a system initialization routine. This routine calls the code of initializing all parts of system. Lots of different activities occur all at init time. So you see that there are number of activities which we need to call, but all need to be called at the init time. So whenever the init method get called, all these routine activities are actually getting called. Then we have procedural cohesion. Procedural cohesion says that elements of a components are related only to ensure particular order of execution. So we need to, relate the elements to ensure that there is a particular order of execution. So for example, actions are still weakly connected and unlikely to be reusable. For example, write output record, then read new input record, pad input with spaces, return new record. So these are activities which need to be arranged in a way so that we can ensure a particular order of execution. So the order of execution we want is like it should, open a file, read that input, put the spaces, again write that file, and then return the record. So we need to make sure that the order of execution is determined in a way that it should always keep a particular order of execution no matter what, and this is a part of procedural cohesion. Then we have communicational cohesion. It said that function performed on the same data or to provide the same data. So the examples are update record in database and send it to a printer. So this is a communication cohesion. So once the records are updated in the database, then only it will be sent to a printer. Or as soon as the records are updated, then we need to send it to the printer. So this depends upon the communication. So there's a communication between two activities. So if there is one, then it's called communicational cohesion, and that means how two components are attached with each other or related with each other to perform some communication. Okay, then it's like fetch unrelated data at same time to minimize the disk access, because although the data is unrelated and we might not need it all of it in one go, but we should fetch it in one go because file operation, reading and writing, is a heavy operation. So we can even fetch all the unrelated data at the same time if we know we'll be needing it. So that's again a part of communicational cohesion. Then we have sequential cohesion. The definition says that output of one part is the input of another. So whenever there's sequence of things such that output of one part forms the input of other, it's called sequential cohesion. So the data flows between parts different from procedural cohesion occurs naturally in functional programming language, and yeah, it's a good situation to keep sequential cohesion. So yeah, that was about sequential cohesion. Let's move forward to functional cohesion. It says that every essential element of a single component is correlated in the component. So that means when every essential element in a single computation. So let's say simple computation is an example where you need to perform some addition. So whenever you perform some addition, maybe you'll be needing different registers or different variables to perform that. So how these variables are related is an example of functional cohesion. Every element and component is essential to the computation, and it's an ideal situation if we can keep the functional cohesion. And what is functionally cohesive component? One that not only performs the task for which it is designed, but it performs only that function and nothing else. So that means if a variable is designed for performing addition, then it should perform addition, and it should not be used, or it should not be used to do any other task. So again, like you can see examples of cohesion. First example is coincidental, where parts are unrelated. So there's a function a, b, c, d, e, and all these are unrelated. Then we have logical. So in, can say in logical, we are having function a, then a dash, and a double dash. All these are connected with some logic. So there might be like, if function a happens, then function a dash happens, so and so. So this is called logical cohesion. Then we have temporal, that is related by time. So if these things need to happen at time t0, then the second one will happen at time t0 plus x, and the third one will happen at time t0 plus 2x. So this is an example of temporal cohesion. And then we have procedural, that is related by function. So these are function a, b, and c, and these are related to each other. So, they are designed to do a particular task, and they should do that particular task. So it could be possible that A, B, and C are related in a way that, finally they are doing a thing that to achieve a single goal. It doesn't mean that the function should do a same thing. Rather, it should mean like, if you are performing something to read from some files, then function A is called to open a file, and function B is open to read from the file, and function C is open to make some changes. So finally, the goal is to update that file, and these functions are helping us. So these functions should be related in a way to perform that cohesion, to perform that functionality that you want to achieve. Okay. Then we have an example of communicational cohesion. It says like accessing the same data. So there are three functions, but all these are accessing the same data. So that is a part of communicational cohesion. Then we have sequential. So that means the output of function A will form the input of B, and the output of function B will form the input of function C. Fine. Lastly, we have functional. That means it should be sequential and should have related functions. So you can see there's a function A and there's a part 1. Then there's again a function A, and it is having another part 2. And then function A is also having part 3. So all these, like there's a function which is having related subpart, and you can say that these are, sequentially accessible within that related function. So that is showing you something called functional cohesion. Okay, so this is a small exercise. So it's saying cohesion for each module. So you need to tell like which cohesion is performed in this. So this exercise, I think I should leave it on you. Like you can try it out yourself, and where the answers for these are easily available. You may find it on internet also. So I'm just pausing so that you can just read this and try to guess the answers for these. So okay, let me just give you an example of one of this. One is like clothes files print average temperatures. So you can see over here this could be an example of sequential because we are firstly we are closing the file and then only we are printing the average temperature. Okay guys, so far we have completed our cohesion and now we'll see what is coupling. So you must have noted when we were reading the good design principle, then we says that cohesion should be high and coupling should be low. So this is something that is, not in demand. We don't want there to be good enough coupling. We rather want our code should have low coupling. So it means degree of the dependence such as amount of interaction among components. So basically coupling in just a simple word means how the components of your code are coupled with each other, how they are dependent on each other. So whether they are dependent or not depends upon the amount of coupling that your code has. So as per good design principle, there should be low coupling. That means, each and every component should rather be an individual component doing a single task, that is a part of cohesion, and it should not be logically dependent on, the interaction should not be dependent, so that, like one component is highly dependent on other and second component is highly dependent on other. So it should not be so. So you can see like we are having three diagrams. First one is showing no dependency, so there is no coupling at all. Then we are having loosely coupled, that is some dependency, so that is fine. Like first part is having a dependency on second, then second one is having a dependency on third, and third is also having a dependency on second. So you can see over here that these are loosely coupled. Then in the third diagram, we can see we are having highly coupled and there are many dependencies. So you can see each and every component is so tightly coupled with each other that each one actually needs another. So all the components are highly and tightly coupled. What we want our code should have is loosely coupled. That is some dependency. So this is what we'll try to achieve. Okay, then how can you tell if two components are coupled? Well, just think about it for 2 minutes and then we'll see. So, indication of coupling. Well, the indication of coupling basically is like to make your mind how the two functions are dependent on each other. You know, if your code says like there is one method which is dependent on another, and then there is a third method which is dependent on second, it's fine. But let's say if you're having five method and you have coded in such a way that each of them is actually dependent on other, so your code will become messy and it will become highly coupled. If there's a failure in one of the method, your whole system goes down. So that is something that we don't want. So this is an indication, like if it's like, so much dependency in there and your code is not written very well, and it's written in a way like each and everything is dependent on other in a way like there is no, if it's like sequential dependency, one is dependent on other and second is dependent on the third, it's fine. But if it's like too much of messiness and too much of mesh that is formed, if you draw the diagram how the things are getting called, then it is actually highly coupled. So you see in this diagram we can say we are seeing high coupling. So high coupling is when we are having a common content. So we should avoid a common content. We need to write something or we need a content, and whatever we need we have written in a way like it is used on number of places, but tomorrow if the requirement comes to change it from the 5 places, then our dependency or our coupling is highly done because we have just written a single code and that is used by 10 places. So it will be difficult because now we need to make the changes such that our 5 functions perform in a different way and 5 perform in a different way. So this is a thing that should be avoided. We should not use too much of common content in a way that it makes your system highly coupled. Then what's loose coupling is means external control stem. It's fine to have external control stem. That means, like for example, internationalization is there, so it's example of loose coupling. So it's okay if we are having an external control. There is an external file or a config file that is, controlling various things in your code, but it's not okay if, it's so tightly coupled that in order to make a change, you need to make a lot of changes in your code. Then we have low. That means data uncoupled. So, low coupling means put the data, if there is a one data and if it's used on 10 places, then you write it differently on each and every 10 places. So that is also not done, because then you're not reusing your code and you're writing your code again and again. So you should, take a decision thinking logically that how do you want to couple your data. So let's see in types of coupling, let's read about the content coupling. So content coupling means one component modifies to another. So the example are components directly modifies another data. Okay guys, so far we have studied cohesion in detail and we have seen what is coupling. In next video we will be covering some types of coupling. So thank you very much for this tutorial. Let's meet in the next tutorial.